this video, we will be discussing about jump game. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. So what they are saying is that in the input, we are given an integer array nums. Now here, the number at each position is denoting that how many maximum jump length that we can have from that particular position. So here a 2 is present. So then that means from this position, we can take a jump of maximum length of 2. That means we can either go to the next index or to this index, right? We can either make a jump of length 1 or length 2. At max, it has to be 2. Right now, initially you are positioned at the first index, basically at the 0th index, and you need to tell whether it is possible to reach the last index of the nums array or not. If it is, then you need to return true, otherwise a false, right? So if we see in this particular case, from this 2 we can either go to 3 or we can go to 1, right? From 3 we can either go to this one, to this one, or to this 4, right? Then from this one we can go to this one, and from this one we can go to here, right? So is there a path through which you can reach from the first index to the last index? Yes, it is. If I go from 2 to 3, then from 3 to 4, I will be able to reach 4, right? And there is one more path that from 2 I go to 1, and then from 1 to 1, and then to 4, right? So in this case, our answer is going to be true. Then if we see in this particular case, so from this 3 we can go to 2, to 1, or to 0. From 2 we can go to 1 or to 0, and from 1 we can go to 0. But from 0 we cannot go anywhere, right? So now if you see, from any of the paths we are not able to reach the last index, right? So in this particular case our answer is going to be false. Now let's understand how we are going to solve this. So for that, let's take one more example. So let's suppose my array is 2, 3, 1, 0, 4, 3. Let's suppose this is the array and the indices will be 0, 1, 2, 3, 4, 5. Right. Now, when I am present at the first index, that is 0, then at max, at which particular index can I go? So this 2 can either go to index 1 or to index 2, right? So then that means at max I can go to index 2. Basically, I am saying that what is the max index where I can go. So initially it is going to be 0, right? Now from this 2, we are at index 0. From index 0, we can go at max to an index 2. Basically 0 plus 2, that is 2. So from index 0, we can at max go to index 2, right? So we'll update it to 2, right? Now let's check for this element. Now from index 1, you can at max make a jump of length 3. Then that means from index 1, you can go to at max 4. That is 1 plus 3. This 1 plus 3, 4. So at max, we can go to 4, right? So our maxi will become 4. Now let's check here. From index 2, we can at max go to next index. 2 plus 1 is 3. We can at max go to 3. But our max is already 4. So there is no need to update it. Then here, since the value is 0, we cannot move anywhere, right? 3 plus 0 will be 3 and it is smaller than the maxi, right? Then we'll check here. Now from this index 4, we can at max take a jump of length 4. That is from 4, we can go at max to the index 8, right? So our maxi will become 8. Now we can see that our maxi has become greater than the last index, right? Or we can say greater than the size of this nums. So then that means it is possible to reach this last index, right? Because when we are at this 4, it's not necessary to take the jump of length 4. We can take a jump of length 1 also and we can reach this index, right? So that is why if for each element we find out that what is the maximum index that we can go to, and if at any point our maxi is greater than this or equals to this, so we can say that we can reach the last index, right? Now let's see another scenario where we won't be able to reach the last index. So this maxi will start from 0, and here let me update this to 2, right? Now in this particular case, what will happen is when you will be at this index, at max you can go to 2, 0 plus 2, 2. So maxi will become 2. Then we'll check here. So from index 1, at max we can take a jump of length 2. 1 plus 2 is 3. So at max we can go to 3. So maxi will be updated with 3, right? Then we'll check for this. So here again 2 plus 1 is 3. So at max we can go to 3. Maxi is already 3, right? Then we'll check here. Now here 3 plus 0 is 3. Max is already 3. Now this one. Should I check this one? See, the maximum index that we have is 3. So that means I cannot reach this point, right? It's not possible for me to reach this index because my max index was 3. So I cannot consider this particular index, right? So if at any point your I, basically we are checking these one by one, right? So you would be maintaining some pointer I. So if at any point this I becomes greater than the maximum index which you can reach, then that means it is not possible to reach the last index, right? So there you can return a false. So this is how we are going to solve this problem. This is a greedy approach. We are just traversing in our nums array. So it is a linear time complexity code. It will be order of n. This will be our time complexity. And space complexity will be constant. We won't be taking any extra space, right? So it is basically that if there are no zeros in the array, then we will be able to reach the last index always. But if there is a zero present, then the answer matters on whether we are able to cross this zero or not. If you are able to cross this zero and go to any index towards its right, then you will be able to reach the last index. Otherwise, you won't be able to reach, right? So let's quickly look at the code. So first of all, we will take the size of the array, nums.size, and then let's create a maxi variable for storing the maximum index, which will be 0 initially. Then we'll run a for loop of I starting from 0 going till n and I plus plus, right? Now inside this, we will check that if at any point Ri becomes greater than maxi, then that means it is not possible to reach the last index. So we will return a false, right? This is going to be the only condition where our answer will be false, right? Then if in any case our maximum index becomes greater than or equals to the last index, then that means we can reach it. It is possible, right? So we can return a true. Otherwise, we will just update our maxi with the maximum of maxi comma. What are we going to do? I plus nums of I. Basically, whatever is the current index and then whatever is the maximum jump length that you have for that particular index, right? And at the end, we can return true, right? Because the false condition would occur here. So at the end, we can return true. So let's run this code. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.